Welcome to August 2nd's LeetCode challenge. Kth smallest element in sorted list, a matrix. Given an n by n matrix where each of the rows and columns is sorted in ascending order, return the kth smallest element in the matrix. Note that it is the kth smallest element in the sorted order, not the kth distinct element. You must find a solution with a memory complexity better than big O of n squared. So we're getting a matrix here, and we want to find the kth smallest element. So the kth smallest element in sorted order would be, so this is the matrix sorted, and the kth smallest element, the eighth smallest element would be 13. So we're given k is equal to 1, and the value of the matrix only has one value in it, which is a 1 by 1, then the value is negative 5. So the constraints are that the length of the matrix is equal to the row of the matrix, which is equal to n. The columns of so it's a square, it's a n by n matrix, square matrix. N is between 1 to 300, and each value of matrix I and j location would be between negative 10 to the 9 and 10 to the 9. All rows and columns of the matrix are guaranteed to be sorted in non-decreasing order, and k is between 1 to n squared. So can you solve this using constant memory? And can you use this using linear time? Alright, so the first thing that pops to my mind is not a memory complexity big O of n squared, better. It would actually be this following: sorted, okay, actually return sorted some matrix, put it in an empty one. So this is not necessarily, this is actually a big O of n, let's see, sorted matrix. This is using big O of n squared time complexity, space complexity, but this should work. This is the first thing that pops in my mind. It's a pretty easy one. It's, let's see, probably might get a time, so that works. However, we should probably use find a solution that has better memory complexity than that. Let's see, we could use a optimal binary search approach. Let's try an optimal binary approach. Say that we have, actually another idea that pops in my mind would be the following. So it's not really a big O of n squared better than memory complexity, but let's try it out. So we have an array, and for row in matrix, and for column in row, you want to append the column to the array, and then you want to sort the array. So basically, you're you're linearizing the array, the matrix, and then you're sorting it afterwards, and you want to return the array's kth minus 1 position, which this is also a big O of n squared time memory complexity, which is not really ideal, but this should also work. So we've done it in 2 ways already. Both of them are not really memory complexity better than n squared.